So in this video, I'm going to give you examples of how to use separation of variables to solve first-order differential equations. So as an example, let's say that we'd like to solve the equation dy over dx is equal to, let's say, x squared y. So the idea in separation of variables is to basically rearrange these differentials, right, in terms of dy over y is equal to x squared dx. Notice we have variables in only one type, Here's your y's, here's your x, and this is separation of the variables. Once we have separation of variables, we can then use an integral operator. So quite arbitrarily, I'll select this integral operator to be taken from 0 to x. So here's my integral operator acting on dy over y is equal to the integral operator of x is equal to 0 to x of x squared dx. We integrate this, we're left with 1/3 x cubed. On this side, we're getting a logarithm function taken from x is equal to 0 to x. And from here, we can see that this will become a logarithm of y at x divisible by y at 0 is equal to 1/3 x cubed. Solving for y at x, we get y at x is equal to y at 0 times the exponential of 1/3 x cubed. So this idea, the main idea I should be getting across, right, is that we want to convert these into groups or symbols, right, that are separated from each other. Once we do, we can apply an integral operator to integrate. So let me do another example just to get the point across. Let's imagine that we have a function So here is xy plus x, and I'd like to actually integrate this. So the first step is I'll notice that x can be factored out into y plus 1 of dy. Then I'm going to multiply by dx and divide by y plus 1, so we get dy over y plus 1 is equal to x dx. I've multiplied through by differential dx, I divided through by y plus 1 on both sides. Then we're going to multiply by an integral operator, and quite arbitrarily I'll stick with x is equal to 0 to x of dy over y plus 1 is equal to the integral operator taken from x is equal to 0 to x of x dx. On this we have 1/2 x squared taken from x to 0. On the other side, right, we have the logarithm of y plus 1 with limits taken from x is equal to 0 to x. So we can basically put these substitutions in here. So the first one is the logarithm of y at x. I'm skipping steps. Y at 0 plus 1 is equal to 1/2 x squared. So taking the exponentials on both sides, we get that y at x plus 1 is equal to y at 0 plus 1, parentheses, parentheses, of the exponential of 1/2 x squared. And subtracting on one side by 1, you get the final solution, y at x is equal to y. So I'm using y at 0 to be y0 plus 1 e to the 1/2 x squared minus 1. So this is a solution. So this is the basic idea of separation of variables. We flip the equation, right, so that we can separate into regions of one variable only. And once we have this, right, we can actually perform an integration by using an integral operator. In this case, I've taken x is equal to 0 to x. Let me do an example. Another example where separation of variables doesn't work. It is the easiest technique for solving a first-order differential equation, but it doesn't work all the time. And so here's an example where it doesn't work. So you begin to see the limits of it. So here is a function dy dx, first order differential equation, and so here's the first order derivative, and I'm going to write this as x plus y, I think is good. Here's an example where we can't do separation of variables. So here's so we can multiply by dx, but the problem is that I can't get two regions, right, of differentials with functions with separable variables. I can't do it. So this is not solvable. Using separation of variables. So you might think that first order differential equations, not all equations are solvable, but when you take ordinary differential equation course, you'll find out that first order differential equations are always solvable. And you can do it by using something called an integration factor. But that's beyond the scope of this video. So either get a good textbook on ordinary differential equation or any ordinary differential equation textbook, and it'll probably be in the first chapter when they're talking about solutions of first order differential equations.